Good morning, dear students. A warm welcome to all of you for today's online session for the subject Science and Technology Section A. In our previous session, we have studied about the two types of spherical mirrors, concave and convex, from chapter number 11, Reflection of Light. We have studied the various terms related to spherical mirrors and also studied about the images which are formed by a concave mirror. As usual, in the first 5 minutes, we are going to revise the topics. We are going to go through the topics which we have studied in our previous session. And our new topics for today are image formed by a convex mirror and mirror formula. So let us begin with our revision part first. We have seen that spherical mirrors are of two types, concave mirror and convex mirror. The basic difference between both of these mirrors are, for a concave mirror, the inner surface of the spherical mirror is reflecting, and for convex mirror, the outer surface of the spherical mirror is the reflecting surface. Now we will just have a glance at the different terms which are related to spherical mirrors. Spherical means sphere. So here the first term is pole, the center. The center of the mirror surface is called its pole. You can see here denoted by capital P, and in this given figure, P is the pole of the mirror. Next you can see here center. The center of the sphere of which the mirror is a part is called the center of curvature, and C, capital C, is the center of curvature in the given figure. Our third term related to spherical mirrors is the radius of curvature. You know, for drawing any circle in mathematics, in geometry, you require the radius, and the radius of the sphere of which the mirror is a part is called the radius of curvature. Length CP, length CA is called as the radius of curvature. The next important term is the straight line which is passing through the pole of the mirror and the center of curvature of the circle or the mirror is called its principal axis, and in this given figure PM is the principal axis. Then we have studied about principal focus, and it is different. You can see here capital F. It is different in the case of concave and convex mirror. And lastly, we have studied about the focal length, the distance between the pole and the principal focus of the mirror is called its focal length. The distance between the pole and the principal focus of the mirror is called the focal length. Now please be careful. The difference between principal focus and focal length is, principal focus is denoted by capital F and focal length is denoted by small f, and focal length distance is half the radius of curvature of the mirror. Now all these terms you have to learn it by heart. As I have told you, it can be asked under a definition, it can be asked under a true or false, it can be asked under an MCQ. So study all the terms related to spherical mirrors. Then for drawing the ray diagrams for image formation by spherical mirrors, there are certain rules which have to be followed. The three rules we have studied yesterday. Let us see each rule one by one. The first rule is, if an incident ray is parallel to the principal axis, then the reflected ray passes through the principal focus. Now the principal axis, principal focus, all these terms we have got introduced to just now. So if the incident ray, the ray which is traveling from the atmosphere and is falling on the surface of the mirror, that is called the incident ray. So if an incident ray is parallel, you can see this incident ray. How you can make out it is incident ray? You can see the arrow is towards the mirror. So if an incident ray is parallel to the principal axis, then the reflected ray passes through the principal focus. This is capital F, principal focus. Rule 2 is contrast to rule 1. If an incident ray passes through the focus, then the reflected ray is parallel to the principal axis. And the third rule is, if an incident ray passes through the center of curvature of the mirror, then the reflected ray, it traces the same path back. So these are the three rules which have to be followed for drawing the ray diagrams for images formed by spherical mirrors. Now, if this question is asked in the exam for 3 marks, along with every rule, diagram is compulsory. So, half mark will be for explaining the rule and half mark will be your presentation in the form of a ray diagram. And I have told you what is a ray diagram. A ray diagram is nothing but the depiction of the path which is taken by light rays. Then we had studied about the image formation by concave mirror. We had taken up 2 examples with the help of diagrams. When an object is placed between the focus and center of curvature, and when an object is placed between the pole and the focus. So quickly we will just see the position of the image, nature and size of the image formed by concave mirrors at different positions of the object. One is when the object is between the pole of the mirror and the focus, the image is formed behind the mirror. It is erect, virtual and magnified in size, means larger in size. When the object is at the focus, that is at the principal focus, the image is formed at infinity. The image is inverted. It is not erect, it is inverted and real. You know, real image means it can be projected on a screen and the size of the image is very large. When the object is between the focus and the center of curvature, this we have seen yesterday with the help of diagram, then the image is formed beyond the center of curvature, nature is inverted, real and the size of the image is magnified. The object is actually at the center of curvature, then the image is also at the center of curvature, inverted, real and of the same size as that of the object. When the object is beyond the center of curvature, here it is at the center, here it is beyond, then the image is between the center of the curvature and the focus, inverted, real and diminished. And when the object is at a very large distance, then the image is formed at the focus, real, inverted and the image is a point image. Just I will keep the table ahead of you. This table is given in your textbook on page number 122. You can just go through it. Now we will start with our today's topic, that is image formation by a convex mirror. Up till now we have studied about the image formation by a concave mirror. Now we will see about the image formed by a convex mirror with the help of this diagram. You can see in this figure an object AB. You can see this is an object AB. It is kept in front of a convex mirror. Now why it is a convex mirror? Because the outer surface of the spherical mirror is the reflecting surface. Here you can see outer surface is the reflecting surface. So it is a convex mirror and you can see this object AB kept in front of this convex mirror. Convex mirror is MN. Incident rays, you can see one is AQ, which is starting from this point A and traveling parallel to the principal axis, and other is ray AR which is going towards the center of curvature. They are clearly shown in this figure. And now how this rays they get reflected and how the image A1, B1 is formed, it can be clearly seen in this diagram. Now looking at the image which is formed, what you can infer about the size of the image? You can see that the image is smaller than the size of the object. So the image formed in the case of a convex mirror is smaller than the size of the object. It is formed behind the mirror and erect in, you can say, position, and as the reflected rays they do not actually cross each other, the image is a virtual image and virtual image cannot be projected on a screen. So you can say over here that the nature of the image formed by a convex mirror, it does not depend on the distance of the object from the mirror, but the images are always virtual, smaller than the object, and always situated behind the mirror. So this is the description about the image which is formed by a convex mirror. In our next topic, that is divergence and convergence of light, we are going to study in details, a small detailed information about both these mirrors. We will take the first one, concave mirror. This is a concave mirror. You can see the inner surface of the mirror is reflecting. Now, a concave mirror is also called a focusing mirror. A concave mirror is also called a focusing mirror. Why? Because the parallel rays, they get focused after reflection in this mirror. They get focused at a single point. And the size of the image which is produced by this concave mirrors, they can be larger or smaller than the object depending upon the distance of the object from the mirror. Now, where such type of mirrors are used? If you want to know about the mirrors, this concave mirrors use, the very important use is it is used by barbers for shaving. The special mirror which is used for shaving by the barbers is a concave mirror, because when held close to the face, it gives vertical and larger image of the face, and if the same mirror is taken farther away from the place, the image gets smaller and smaller. So when you can use a concave mirror is when we want to bring light rays together at a point, a converging light beam is used. This concave mirror is also called as converging mirror. Why? Because it converges the light rays and brings together at a point. When you want something to get focused at a point, then you will use concave mirror. For example, if you take doctors, they make use of concave mirrors. They want a beam to converge light. Now when they have to watch the minute parts of the body, such as they have to focus on the tooth, if there is any tooth decay and they want to just clean it and all, then they require the light rays to get focused at that particular point. Or they want to clean your ears, nose, etc. In such cases, the doctor is going to use concave mirror, because they want the light rays to get focused at that particular point, so the defects and all can be detected and treated properly. In other way also, equipments using solar energy, they also use converging light, because the light rays coming from the sun in the form of solar energy, they have to be brought together at one point so that the food can be cooked properly in a solar cooker or solar heaters and all, where you want to bring the light rays at a point, converge the light rays at a point, there you are making use of concave mirror. The next exactly opposite to concave is your convex mirror, which is known as dispersing mirror. Why it is known as dispersing? You know the meaning of dispersing. From a single point, you are scattered in different directions, because the parallel incident rays, they get dispersed after reflection. You can see in this mirror. Here, the size of the images which is produced by convex mirrors is always smaller than the size of the objects. Now, when you might imagine that this convex mirrors and where they are used, when you want the light rays to get dispersed, the light rays to get diverged from a single point, then you use convex mirror. For example, street lamps. During the night time, you want your entire road to be lightened up. So in one lamp, from that point source, you want the light rays to get dispersed in different directions so that the entire road is lightened up. There you use convex mirror. Or the mirrors which are used in cars and motorcycles, they are also convex mirrors. Why? In this mirrors, the image of the face is erect and smaller, and it remains erect but becomes smaller and smaller when the mirror is taken away from the face, and as a result we can see the images of the surroundings also in the mirror, and hence motorcycles, cars, etc. they make use of convex mirror. So when we want the light rays to spread out from a source, a divergent beam is used, for example in street lamps or the mirrors which is used in cars and motorcycles. I hope you have studied about both the mirrors and their uses. Actually, the uses part on page number 125 they have removed out from the syllabus, but for your understanding I have discussed the uses with you. So always remember concave mirror, focusing mirror, converging mirror. It is also called as converging mirror. It is used by doctors or solar equipments. They make use of concave mirror. Convex mirror, dispersing mirror. When you want the light rays to get dispersed from a source, it is also called as diverging mirror. For example, your street lamps or the mirrors used in cars, motorcycles, etc. They are convex mirrors. Now, let us move towards the Cartesian sign conventions. For the, you can say, we have to see how the distances are measured for the mirror, how the object is placed. So let us see with the help of a diagram. Now, what sign conventions are used for reflection from a spherical mirror that we are going to study here? Now, according to the Cartesian sign convention, here the pole, you can see this is the pole. The pole of the mirror is taken as the origin. You know 0, 0 is the origin which is taken while plotting a graph. Now here it is little bit applicable in the case of graphs and all when we draw. The principal axis, this is your principal axis. It is taken as the x-axis of the frame of reference. You know x-axis and y-axis in graph. Now, what are the different sign conventions which are used over here? The first sign convention is the object is always kept on the left of the mirror. The object is always kept. It is always placed on the left of the mirror, and all the distances parallel to the principal axis, they are measured from the pole of the mirror. So, what is the pole? The pole is the origin. Next sign convention is all the distances measured towards the right of the pole are taken to be positive, and those measured towards the left are taken to be negative. See, distances on the right positive, distances on the left negative. Third is distances measured vertically upwards from the principal axis. This is your principal axis. So the distance which are measured upward from the principal axis, they are taken as positive, while the distances which are measured downwards from the principal axis, they are taken to be negative. And the last one is the focal length of a concave mirror is negative, while that of a convex mirror is positive. Fifth point is very, very important, because while solving the numerical examples, you have to take into account the focal length. Once again, we will see the Cartesian sign conventions. According to the Cartesian sign convention, as I have told you, the pole of the mirror is taken as the origin, and the principal axis is taken as the x-axis of the frame of reference. Then which are the different sign conventions? The object is always kept on the left side of the mirror. The distances on the right of the pole are taken as positive, whereas the distances measured on the left of the pole, they are taken as negative. All the distances which are measured vertically upwards from the principal axis, they are taken as positive. Vertically downwards are taken as negative. And last and very important is the focal length. What is focal length? You all know. What is focal length? The distance between the pole of the mirror and the principal focus. So the focal length of a concave mirror is negative, while that of a convex mirror is positive. So while solving a numerical example, they will only give that in case of a converging mirror, the focal length is so and so. So while writing down the information given, so if it is a converging mirror, if it is a concave mirror, then focal length you will take as negative. But if it is a convex mirror, then you will take it as positive. They will not mention in the question. Now lastly, very simple, we are going to study about the mirror formula. Now we get the correct values of the distances by using the Cartesian sign convention. Here the mirror formula says 1 upon V, plus 1 upon u is equal to 1 upon f. Here you have to take care that v, u and f are all small letters, where u is the object distance. Object distance means the distance of the object from the pole of the mirror, because just now we have seen that the pole is taken as the origin. So object distance is the distance of the object from the pole of the mirror. What is v? V is the image distance. It is small v, the distance of the image from the pole, and the relationship between the object distance, the image distance and the focal length is called the mirror formula, that is 1 upon v plus 1 upon u is equal to 1 upon f. And this mirror formula is extremely important because you have to apply it while solving our numerical examples. And lastly, the last topic of your chapter is magnification due to spherical mirrors. Now, magnification due to a spherical mirror is given by the ratio of the height of the image h2 to the height of the object, that is small h1. It is the ratio of height of the image to the height of the object. Magnification due to spherical mirrors is denoted by capital M. So magnification is what? Ratio of height of the image to height of the object, that is h2 upon h1. It can also be shown as M is equal to minus V upon U. You have to remember this formula, very important again for numerical examples. Now here some information you have to remember, that we have seen in the Cartesian sign convention that the object is always kept above the principal axis. So its height is always taken to be positive. So the height of the object is always taken as positive. In the case of virtual images, means for virtual images height is positive, but for real images height is negative. And as the object is always kept on the left of the mirror, the distance u is always taken as negative. Why? What is u? The distance of the object from the pole of the mirror. And where is the object? Object is on the left side, and distances on the left side are always negative, and hence u value is always taken negative while solving numerical examples. Let us go through the mirror formula and the magnification formula once again before we move towards the textual exercise. Mirror formula says 1 upon v plus 1 upon u is equal to 1 upon f, where f is the focal length, v is the image distance and u is the object distance. Magnification due to spherical mirror is the ratio of height of the image to the height of the object, that is h2 upon h1. Magnification capital M is equal to minus v upon u. With this, we complete with the explanation for chapter number 11. Now the textual exercise, numericals and additional questions for this chapter are remaining. So there is still some time. So let us just start with the textual exercise. I request all of you to please take the textbooks in your hands and move towards the textual exercise for chapter number 11. We will first begin with question number 2. We have just now studied about the Cartesian sign convention, so your answer will be in that slide only. So we start with question number 2 first. Question number 2 says, what sign conventions are used for reflection from a spherical mirror? It can be asked in the exam for 5 marks, and if it is asked for 5 marks, then you have to express it along with the diagram. So clearly this answer is given in your textbook on page number 125. So mark it properly. It can be asked for 5 marks. So mention there 5 marks. What sign conventions are used for reflection from a spherical mirror? Page number 125 in your textbook, you can see that peach colored block in between. Start marking over there. According to this Cartesian sign convention, the pole of the mirror is taken as the origin. The principal axis is taken as the x-axis of the frame of reference. After this information, you have to draw this diagram. Drawing of the diagram is extremely important. Without the diagram, your explanatory part will have no meaning. Now start marking. Point number, all 5 points as they are given you have to write in the exam. The object is always kept on the left of the mirror. Along with this point you have to add from the textbook. All the distances parallel to the principal axis are measured from the pole of the mirror. Point number 2, all distances measured towards the right of the pole are taken to be positive, while those measured towards the left are taken to be negative. Point number 3, distances measured vertically upwards from the principal axis are taken to be positive. Distances measured vertically downwards from the principal axis are taken to be negative. And lastly, the focal length of a concave mirror is negative, while that of a convex mirror is positive. So for 5 marks, you have to give all these 5 points along with this diagram and the information which I have given you in the previous slide. So entire that peach colored block is your answer for question number 2. So question number 2 is over. Now let us begin with question number 1. Sub questions are there. It will not get over today. So let us at least try to complete the first answer. Question number 1A. Explain the difference between a plane mirror, a concave mirror and a convex mirror with respect to the type and size of the images produced. You have to explain the difference. It is a type of distinguish between the three mirrors and with respect to which points, the type of the image and the size of the image. So you have to make 2 columns. One is type of the image, one is size of the image. In the case of plane mirror, concave mirror and convex mirror, it can be asked for 3 marks in the exam, half per point. In the case of plane mirror, you all know that the type of image is virtual and erect, and the size is, the image which is formed is of the same size as that of the object. So the size is same size. You have to note it down somewhere. It is not given in the textbook. It is just given in the textbook in different slots. So we have to combine the answer. In the case of concave mirror, the type of the image is virtual, erect as well as real inverted. And size of the image is diminished, same size and magnified. All the 3 types we have seen in the chart. In the case of convex mirror, the type of the image is virtual and erect and diminished. Size of the image diminished. I repeat once again. You have to first make 2 columns. Type of the image, size of the image, then all the 3 mirrors they have told. So write the names: plane mirror, concave mirror, convex mirror, and then you mention about their type and size. It can be asked in the exam for 3 marks. So half mark per point. Half mark for type of image for plane, half mark for size of image for plane mirror, similarly for convex and concave mirror. So we will stop today with the discussion of question number 1A. Question number 1B you omit. Question number 1B is omitted. Why? Because see the question. Describe the positions of the source of light with respect to a concave mirror in torchlight, projector lamp, floodlight. That is on page number 125. The answer is in the blue block. And that entire blue block they have removed out from our syllabus. So whatever part is removed out from the syllabus, no answers will be discussed, neither they will be asked in the exams. So we complete and we wind up our today's session by completing up to question number 1A, and question number 2 is also over. So in our tomorrow's session we will start with question number 1C. Till then, I will request all of you, whatever topics are covered today, go through the topics, complete your notebooks, and children really start studying because it is the high time now. Your second online assessments are coming near. So reading the textbook, studying the concepts at the same time, your book completion is a must. Thank you, dear children.